we have this matrix A equals to 1 minus 1 0 0 1 minus 1 and 0 0 1. Right, most of these are zeros and ones and minus ones. So matrix multiplication should become easy. Now we are given this matrix B. What is this B? B is 7 into a power 20 minus 20 into a power 7 plus 2 into identity matrix. B is clearly another 3 by 3 matrix. Now, in this 3 by 3 matrix, what is this element? B 1 3. That is first row and third column. What is this element of this B? Right. Now, a power 20, a power 7 is given, and most of these are zeros, ones, minus ones. So, there must be some pattern in this a powers, right? A powers, a square, a power 4, a power 10, whatever, there must be some pattern. Let us try to identify what is that pattern. Okay, so let's do a square first. A square, a into a, if we multiply this, then we are getting, and both are upper triangular matrices. So obviously these three will remain zeros, and then the diagonal is still 1, and then this minus 1 is becoming minus 2, and this 0 is becoming 1. Very good. If we multiply this a square again with a, we are getting this matrix a cube. A cube, again, these three are zeros and the diagonal is 1. At the same time, this minus 2 is becoming minus 3 here, and this 1 is becoming 3 here. This is a cube. Okay, a cube, this is clearly, this is minus 3, this is minus 3, and this is what? This is 3 into 3 minus 1 by 2. Basically 3 into 2 by 2, which is equal to 3. So similarly here, these are zeros and these are ones, and this is minus 2. At the same time, what is this? This is 2 into 2 minus 1 by 2. Basically, this is equal to 1. Similarly, a power 4. A power 4, naturally, this one will become minus 4, and this one is what? 4 into 3 by 2. That is 4 into 4 minus 1 by 2. So clearly we are able to see one pattern. What is that pattern? A power n equals to, this diagonals is anyway ones, and these three are zeros, and this one is minus n, this one is minus n, and this one is n into the previous number, n minus 1 by 2. That is this element. We are concerned about this element only. So, right, now if you want to prove this, a power n is this, we have proved, we have shown this for 2, 3 elements. 2, 3 multiplication doesn't mean that a power n will always behave like this. Right, for that we use mathematical induction. Let's say it is true for 2, it is true for 3, and assume, let us say this is true for n. Then it should be true for n plus 1 by mathematical induction. If it is true for n plus 1, then we can say this is valid, right? This is proved, right? Let us take this case, nth case for n, and multiply with a again. So basically 1 minus n and n square minus n by 2, right? This is a power n, this is a power n into a. If we do this multiplication, then this first row into first column, we'll get only 1, and first row into second column, we'll get minus of n plus 1, and first row into third column. What we are getting? 1 into 0 minus n into minus 1, that is plus n square minus n by 2, n plus n square minus n by 2, which is nothing but, if you simplify this, n plus n into n minus 1 by 2, which is nothing but 2n plus n square minus n by 2, which is nothing but n into n plus 1 by 2. So this element is nothing but n into n plus 1 by 2. So obviously, what does that mean? N plus 1 into n plus 1 minus 1. This n is n plus 1 minus 1. So which is our regular format which we have stated, right? So that means by induction also we are able to prove that a power n plus 1 is in the form of a power n. So a power n equals to 1 minus n and n square minus n by 2. This structure is actually proved, and this is valid structure and valid formulas here, right? Now what is our question? Our question is 7 into a power 20, 7 into a power 20, and minus 20 into a power 7 plus 2i, a power 7 plus 2i, and we want this element only in all the three cases, because we want b13 only. So 7 into a power 20, a power 20 will have this element as 20 into 19 by 2, and a power 7 will have 7 into 6 by 2, this element, right? So 7 into a power 20, this element is 7 into 20 into 19 by 2 minus 20 into 7 into 6 by 2 plus 2i. I will have anyway this element as 0. Right, this element is anyway 0, so 2i is anyway 0, so it doesn't contribute anything. So if we simplify this, we are getting 910. So 910 is the correct answer. Right. The problem, only little trick here is to be able to generalize a power n and be able to prove using mathematical induction also. In exam, in this case, you don't need to prove, but we should know how to prove this also using mathematical induction. When we say a power n is this, we should be able to prove this using mathematical induction.